So students, today in this video we will solve a numerical from your gravitation chapter, and this question is a PYQ, previous year questions from your IIT, and it came in 2010. So the question is about the gravitation, the work done, and work done work required to take a unit mass from a point P on the axis to infinity. So let me explain you the question. This is a thin uniform annular disc. This is an annular disc, and on the point, on the axis, a point P is there. You have to find that from this point to infinity, if you will take this unit mass, so what will be the work done, or how much work you need to do for a unit mass if you will shift from point P to infinity. And this point P is at 4r from the center, and this is an annular disc. So this disc outer ring of outer radius is 4r and inner radius is 3r. So we have to find out basically how much work done. So work done means for a unit mass, if you are finding out the work done, then it is potential. Basically you have to find the potential. So potential due to ring at this point P, potential at infinity, we will find out that will be 0. So we will subtract that and we will get how much work need to be done. The potential difference basically will give us the work done. So first let us find what will be the potential due to this annular disc, disc at point P 4r from the center. So you know the potential, formula of the potential, that V is your V at point P, we will find out, and potential you know that is Z, and M by R. This is the formula for your potential, minus Gm by R. So what you will do, we need the mass of this annular ring. So for that we can cut this annular disc in small rings. We will cut it in small rings of width, let us say dx, and this dx will be integrating from 3r to 4r. This is a point somewhere here. So the distance from this dx to this point, it will be like this one is x, this is your 4r. So this one is the distance from the your this ring, the ring to the point P. So this one will be using Pythagoras theorem. It is 4r square plus x square under root of 4r whole square plus x square under root. This will be the distance. So this will be your r. So basically your r is here, that point P, that is 4r square plus x square under root. This is the distance of the point P to this x. Now we are interested upon the mass. What is this mass of this small ring? Then we will integrate it. So for that what we can do, first let us find out, let us say that it is a uniform annular disc. So let us, mass of this disc is m. So what will be this mass of a ring? Now area of the ring is, it is at a x distance we have cut the ring. So area of the ring is 2 pi x dx. This is the circumference into dx. This is the area of the ring, area of ring. Now what is the area of the disc? The area of the disc, you can say area of the disc is the pi r square is area. So r is 4r minus 3r. So we can write area of the annular disc, area of annular disc is pi 4r square minus pi 3r square. This is the area, or you can say this is pi common 16r square minus 9r square. So this much of area is equal to, you can say, mass m, right? You can use the unitary method, or you can say for unit area, you subtract it So you can write this is your pi 7 pi r square. So this is the area of the annular disc. Now this 7 pi r square is the mass m. So unit area is m by 7 pi r square, and for this area, this is the area of the ring. So ring area, what will be the mass of this ring? So mass of the ring will be your 2 pi x dx. So its mass will be m by 7 pi r square multiplied by 2 pi x dx multiplied by 2 pi x dx. So this is the mass of the ring, that is, let us say small dm, we can say mass of the ring. So what we will write is, we got the mass of this ring and we will integrate it. So the potential we will write, that is integration minus g outside integration dm. Dm is the mass of the small ring by r, distance is this one, that is 16 r square plus x square under root gm by r. Now dm will replace, this is your dm value, mass of this ring, so we will replace it, we will get minus g, your dm is capital M by 7 pi r square 2 pi x dx, right, 2 pi x dx, m by 7 pi r square 2 pi x dx, and this is your dm, and divided by under root 16 r square plus x square, 16 x square plus r square. Now if I will take it outside the constants, so I will get g m 7 pi r square, gm 7 pi r square, or you can say, you can cancel out this pi value. So pi will be cancelled out. So 7 r square, gm by 7 r square, and 2, let's keep the 2 inside, 2x dx by 16 r square plus x square. Now you can see, you can use the substitution easily. Substitution, how will you use? Simply you can put keep this one or take this one, 16 r square plus x square is, let us say, z. So if you will find the derivative of this, so this one is 0 constant, x square derivative is 2x dx, differentiating both sides, this will be dz, 2x dx is dz. So this one we can convert, and integral, if we are converted to dx, dx is changing from 3r to 4r, we can put the limit, this is 3r to 4r, this is also 3r to 4r. Now if we will convert this, so this will be dz by root z, right. So it will be dz by gm by 7 r square. I am not converting the limit, because I will again convert back to x again. So what I will do, 3r to 4r, and this is dz by root z. So the integration of dz by root z is 1 upon root z is 2 root z. So basically you will get, okay, let me do here. So you will get minus gm by 7 r square, and this is 2 root z integration 3r to 4r. So this limit are in x actually, so we have to convert this z again. Z we have considered this one, so you again replace it, 2 take it outside, so minus 2 gm by 7 r square and this root z is 3r to 4r, 3r to 4r, and this root z is 4, this is 16 r square plus x square root z, 16 r square plus x square, and okay. So this one you can put the values actually, 3r to 4r you can write, because already we have completed this integration 3r to 4r, but this one will be in terms of x only, so we have to convert it in x. So again I have replaced the value of x and 3r to 4r. Now you see, just put the values, minus 2gm by 7r square, 2gm by 7r square, and this one is your 16r square plus x is 4r, so it's again 16r square under root minus 16r square plus 9r square under root. So you can say, or I'll do it, okay, let me do it here only. So it will be minus 2gm by 7r square, 2gm by 7r square. Let me zoom it, else the things will not be clear. Right. So 2gm by 7r square, and this is 16r, so 16r square, so LCM will be 4r, 2 into 16r square, so it will be 4r root 2 or 4 root 2r you can say, and this is your 16r square plus 9r square, 25r square, so 25r square is 5r. So again what will take? You will take r common, so you can write r common, or you can write okay, r you can take this r square you can cancel, r will come outside. So finally what you are getting? Finally you are getting minus 2 gm by 7r, and this is 4 root 2 minus 5. This is the result you are getting for the point that is at P. This is the potential you are getting. Now potential at infinity is 0, right? Potential at infinity is 0. So work done for shifting this point from point P to infinity. So basically V infinity, this work done is V infinity minus V point P. So V infinity is 0 minus of this number. Minus of this number means this one will become plus. So it will become plus, minus minus plus 2gm by 7r and 4 root 2 minus 5. So this is the answer. So the answer, let me write again. So let me again write the answer, that the work done for taking the unit mass from point P to infinity, it is 2 gm. It is 2 gm by 7r, 4 root 2 minus 5. I hope this is clear. For an annular ring we have done it, and we will solve some more numericals in the next classes. Thank you for watching. Subscribe to the channel and share those who need it. they are preparing for IIT JEE. Thank you.